I'm going to be going through the entire lesson with this one. So we'll stop at different spots and have you kind of do some work and you can check your answers. But this video is going to be a little bit more lengthy just because it covers the entire lesson. So we're still dealing with functions on this one. And f is a word that we use a lot, or a letter I should say, that we use a lot with functions. It'll have this f and then this parentheses here in place of the y. You won't see that. You'll see this f of x. We read it as f of x. This isn't f times x, so it's a little bit different. It's called function notation. All right, so if we look at this one here, we're asked to evaluate this function if x were to equal -3. So we've got this here. This is f of x equals 4x minus 2. Well, if x equals -3, what we're going to do is just basically plug in this -3 for x. Anytime we see an x, we plug in -3. So we substitute that -3 in. Notice I did it in both places. I like to do that just to keep it simple and easy, because this is actually f of -3 is equal to this. And you notice how I use parentheses to plug this in. That will make a lot of difference in a lot of different ones that we actually go through here. You'll get the right answer as long as you're using these parentheses. Now for this one on the right hand side here, we can just take that and plug that exactly into our calculator, just how it appears. That will work fine. If you don't need to though, you don't want to, that's fine. We know that 4 times -3 is -12, so you end up with a -12 minus 2, which is -14. So f of -3 is equal to -14. So the answer that we'd input for our homework would just be -14. That would be fine. Well, let's look at another problem here. I'm going to keep this one up just so you can reference it. If this is g of x, so if g of 7 is what we're looking for. So now we're going to plug in this 7 right here for x. All right, so let's bring that in. We'll plug in the 7 for x. Notice my use of parentheses here. If you don't use parentheses here, you're going to try to interpret that yourselves as a -7 squared. Well, instead it should be 7 squared, then we take it and multiply it by the negative. If you plug it into your calculator and you're plugging it in just like this one on the right-hand side, you'll get the right answer. That will work, as long as you're using those parentheses. Well, we know that 7 squared is 49. Times a negative would be -49. So we've got -49 plus 6 would give us -43. So g of 7 is -43. So our answer on this one is -43. All right, now I'm going to put some up there. I'm going to have you work through these. Here are 2 of them. I'd like you to do both of these problems right now. Go ahead and push pause on the video. After you've obtained your answer, come on back and push play. Check your answers here. You had a -43 on this one here, and over here you had a +1. And all we're basically doing is we're plugging in this case for the second one that we have here, we're plugging in 2 for x, and that's really all we're doing on it. All right, so let's try another one. I want you to try it on these 2. Here is the original equation. This is the function h of x. So now I want you to find h of 4 and h of -2. Go ahead and try that now. After you've obtained your answer, come on back and push play. Check your answers here. So hopefully on this one, if you got a different answer, hopefully you can identify that you need to use those parentheses here. This is -2 squared. -2 squared is 4. We do that first, then we multiply it by the 2. That's our order of operations. Okay, we're not going to go 2 times -2 times 2 is -4, and then square that, which would be 16. So if you got 16, that was your error on this one. Same thing on this one over here. We have to take the 4 squared first before we multiply that by 2. Those are some common errors that we see. All right, so here is one. We're going to get into a lot more real-life application now. So on this one, the number of hotel projects in the United States starting in the year 2007 all the way to the year 2015 can be modeled by this function. This is the function h of x is equal to this function right here. The important part here, and it always kind of gives you a little key, if you will, x is the number of years after 2007. So in 2007, x is 0. In 2008, x is 1. Let's say if it's in 2010, x is 3. That'd be 3 years after 2007. So it says how many new hotel projects will there be in 2013? Well, in 2013, we've got to determine what our x value is going to be. So we look at this one. Well, it represents the number of years after 2007. So 2013 is 6 years after 2007. So x should equal 6. So let's write that down. X would equal 6 in the year 2013. So now what we're going to do, now that we know that x equals 6, we're asked to, this is how many hotel projects will there be? So now we're going to plug this 6 into this function here, and that will tell us how many hotel projects there will be. I'm going to plug in 6 for x. So here is our original function here. This is the same one that I have up here. I just rewrote it. Now what we're going to do is plug in the 6 every time we see the x. And I always use the parentheses there. That makes it really easy. I highlighted them in blue just so you could see where I got those. Instead of x, I'm just writing 6. That's it. And I use parentheses here. Now we just have to simplify this. Just plug this one into your calculator, and you'll obtain your answer. You find out that h of 6 is equal to 164. Now we have to interpret that. Now we have our answer. Our answer is 164. But 164 what? So this is the number of hotel projects in the United States. So that means in the year 2013, because that was our x equals 6, in the year 2013, the number of hotel projects are 164. Using this function here, we can predict how many new hotel projects there will be. Okay. We can also use that using the table button on your calculator. We won't really get into that here. All right. Now we're going to switch off just a little bit here. This looks like a very weird, a very complicated formula. This is what we call a piecewise function. So piecewise. And it's really not as bad as it looks. We'll kind of go through it one by one here. If we were asked to find f of -2, so the way that we use this here, this is kind of our formulas, our keys here, what we do. -2, we have to find out if x were to equal -2. We use this formula here if x is less than 0. This middle formula we use if x is greater than or equal to 0 or less than 4. And then we use this one here if x is greater than or equal to 4. So we have to basically go over here and we go, okay, x is equal to -2. So -2 is definitely less than 0, so that means I'm going to use this formula right here. I'm not even going to worry about the second one or the third one at all. The first one is the only one that this one applies to. So I'm going to plug that in to this formula here, and that one is x squared. So I take x squared, I plug in my -2 there, so f of -2 is equal to 4. Okay, now we've got that one down. Now let's look at another one. So if we're asked to find f of 7 is 7 less than 0? No, 7 is not less than 0. It's not between 0 and 4, but it is greater than 4. So that means for this particular one, I'm not going to use the first two equations. I'm going to use this third one. So I only need to worry about this third one. That's it, because 7 is greater than 4, greater than or equal to 4, so I'm okay there. So I take that third equation, I just rewrote it, same exact equation that I've got up here, I just rewrote it. Now all I'm going to do is plug in 7 for that x. I plug in 7 for x, that's 4 minus 21, 4 minus 21 gives me -17. So f of 7 is -17. All right, now on this one, let's talk just for a moment here. If I have one, let's say if it were f of 4, I've got two 4's here, f of 4, but this one says that x is less than 4. 4 is not less than 4. This one here says x is greater than or equal to 4. So in that case, if we were trying to find f of 4, we would use this third equation. We would not use the second one at all. And same thing for 0. If we looked at 0, x less than 0, we would not use the first equation. We'd end up using this second equation. All right. Now I've got 3 of them here. I want you to go ahead and I want you to try all 3 of these. So the very first thing you do, you got this f of 5. You look at 5. 5, which one does this fall into? Which category? You're going to use one of these 3. You don't have to use all 3. You may use all of the same one. That's okay too. All right, so go ahead and push pause now. I'd like you to work through these after you've obtained your answer, then come back and push play. Check your answers here. All right, so the big one here that sometimes students get mixed up on is this -10. So this -10 here, we have to look at this. Now this one is x is less than or equal to -10. So that means we're going to use the first equation. This one here, x is greater than 10. 10 is not greater than 10. It is equal to 10. So we use the first equation there. So hopefully you're starting to kind of get the feel for these just a little bit. Now you notice on this one that I used all 3 equations. I used this one here is the first one, and this one is the last one. That's just by chance. Sometimes I will not use one of the equations. Sometimes I'll only use one. That's it. So I want you to go ahead and try all 3 of these. Push pause now. After you've obtained your answer, come back and push play. Check your answers here. So you'll notice on this one that I only used the first and the second equation. I never used this third equation at all. It just didn't work out that way. We've got our -5 here again. -5 is less than or equal to this x here. So that's why I used that second equation. All right, hopefully you're starting to kind of get the feel for these here just a little bit. Now, Dillard's is having a sale. If we were to spend $50, you receive $10 off your purchase. If you spend $150, then you get $40 off of your purchase. That's a fantastic sale. So we want to make our own equation for these that would define these. So we've got one here. This says x is less than 50. And x represents the amount of money we're going to spend. So if we spend less than $50, what's my equation going to be? Let's say if I spent $40 at Dillard's. Well, I wouldn't get any discount, so I just be $40. So this one would just be x. Now if I spend between 50 and 150 on this one, then I get $10 off. So it'd be x would be the amount that I would spend, and I say I get $10 off, so it'd be x minus 10. And then finally, if we spend over 150 or equal to 150, then we get $40 off, so that would be x minus 40. So we'll go through each one of those, x minus 40 here. X minus 10, this one's just plain old x. If we spend $40, we have to pay $40, that's it. We're not assuming any tax at this point. We can get into those a little bit later on, but you use these quite a bit whenever you go shopping. Any of those, if you spend a certain increment, then they'll offer free shipping, that type of thing. So that will change your functions on these. All right, so let's get a little bit more practice on those. I want you to go ahead and try these three. Push pause when you're done. Then you can come on back and check your answers. Check your answers on these. Indeed, we had all three of them on there. So 45, if you spend $45 at Dillard's, you end up paying $45. If you spend $200, then you get $40 off, so that leaves you with $160. And then if you spent $100, then you get your $10 discount. So that puts you at $90 there.